In this video, we're going to learn some of the basic functional groups in organic chemistry. So by the end of the video, you should be able to define and identify the basic functional groups within organic molecules. A functional group is a characteristic group of atoms or bonds that possess a predictable chemical behavior. Using line bond structures or bond line structures helps us identify the types of transformations that take place and identify what types of functional groups are undergoing transformation or changes. So for example, if we take this compound, we can see that this compound has a double bond in it. If we take this compound and we add hydrogen, it forms this new compound without the double bond. So the double bond is converted into a single bond. Well, rather than just saying single bond, double bond, we have names for these particular groups. So quick note, here are some examples of some common functional groups. And I'll let you know the ones that are the most important and the ones that you need to know. A quick note though is you'll see that there is an R attached in a lot of these. The R is an abbreviation for the rest or the remainder of the molecule. It's what's attached to our particular functional group. And it usually contains carbons and hydrogens. So let's take a look. Our alkyl halides. So we have a halide, a halogen, chlorine, bromine, or iodine attached to a regular molecule, to carbons and hydrogens. So this is an example of a functional group. We'll refer to these as alkyl halides. Alkenes. Alkenes contain a carbon-carbon double bond. Alkynes contain a carbon-carbon triple bond. An alcohol. An alcohol contains carbons and hydrogens bonded only to an OH. There are other functional groups that have OHs in them, but this is the only one that's in there. We have an ether. An ether is where we have an oxygen in the middle of two carbons. A thiol is similar to an alcohol, except that at OH we have an SH. A sulfide. A sulfide is similar to an ether, except we have an S in the middle of the two carbons. We have an aromatic or arene. That is a cyclical carbon, 6 carbons alternating double bonds. That's called an aromatic or an arene. We have a ketone. This contains a carbon-carbon or carbon-oxygen double bond. That double bond oxygen is in between two other carbons. Similar is an aldehyde. The big difference between an aldehyde and a ketone is rather than being attached to another carbon, there is a hydrogen on the end. Another common one is a carboxylic acid. Again, there's an oxygen double bond, and then there's an OH. So this can be sometimes confused with an alcohol because we see the OH, but if we have the double bond oxygen attached to the OH, that is a carboxylic acid. An acyl halide, similar to an aldehyde, except we have a halogen attached instead of a hydrogen. An anhydride, oxygen, two double bond oxygens. Probably won't deal with anhydrides very much. An ester, instead of like a carboxylic acid where there's an OH, there's an R attached, something else. An amide, double bond oxygen and a nitrogen, and more importantly, an amine. An amine has a nitrogen attached to 3 carbons. So which are the really important ones, the ones you need to know? Alkyl halide, alkene, alkyne, alcohol, an aromatic or an arene. You need to know ketones, aldehydes, carboxylic acids, and amines. Those are the most common ones that we'll be discussing, especially in the first portion of this course. So you'll need to memorize those because we'll refer to them. I'll say, okay, we're talking about alkenes, and you need to know that an alkene contains a carbon-carbon double bond, or an alkyne, carbon-carbon triple bond, and so on. So let's look at a couple of examples. Let's identify the major functional groups in several common molecules. For example, cholesterol. We've all heard of cholesterol. So cholesterol, we see that there's an OH, so that would be an alcohol. So the cholesterol molecule, and something in the name tells us alcohol, cholesterol, OL. So sometimes the name will give us a little bit of a hint of what functional group is in there. And then we can see that there's a carbon-carbon double bond, or an alkene. All right, let's go ahead and look at testosterone. Testosterone, double bond oxygen. Remember, that's our ketone. Again, gives us a little bit of a hint sometimes. Also, we can see that there's a carbon-carbon double bond, or an alkene. And then we also see that we have an OH, or an alcohol, within our testosterone. Let's look at ibuprofen. Ibuprofen. Okay, we can see we have that six-membered ring, alternating double bonds. That was our arene, or an aromatic. Now this last one, need to be careful. There's our double bond O and an OH, so that will be our carboxylic acid. So these are ways in which we can refer to some of the major functional groups within molecules.